Hello, lovely people. Welcome to another video where we are looking at straight line equations. This is part 2 of our miscellaneous examples, where we are looking at the kinds of questions that trip people up because there are so many moving parts, not because each individual thing is really difficult. So it will involve straight line equations. It will involve looking at parallel and perpendicular lines, the distance between 2 points using Pythagoras' theorem, midpoints, intersections of lines, which involves solving simultaneous equations, and rearranging formulae, or changing the subject. I encourage you to watch part 1 if you haven't already and give those questions a try. We are going to look at part 2, where we look at a multitude of different things, but all related to straight line equations or coordinate geometry. So, brushing past part 1 and part 2, questions A and B, we are now looking at question C. So this says, you're given the line L1, y equals minus a half x plus 3. It says, write the equation of a line parallel to L1 that passes through the point 4 minus 2. Okay, so we have, first of all, just a straight line equation in general has the form y equals mx plus c. If it's parallel to L1, well, the gradient of L1, because it's in the form y equals mx plus c, the gradient is minus a half x. When lines are parallel, it's got the same gradients. So we can say that y equals minus a half x plus c for our general equation. And for it to pass through the point 4 minus 2, well, we need to sub x equals 4 and y equals minus 2. Okay, so we have minus 2 equals minus a half, not times x, but instead times 4 plus c. So we have minus 2 equals minus a half times 4. Well, that's minus a half times 4 over 1 plus c. So minus 2 equals, that's minus 1 times 4 is minus 4 over 2 times 1 is 2 plus c. Minus 2 equals, well, minus 4 divided by 2 is minus 2 plus c. Minus 2 equals minus 2 plus c, which means that c is going to be equal to 0. So our final equation is y equals minus a half x plus 0, but that's just the same thing as y equals minus a half x. Okay, so that's part 1 done. Let's change it up with the colors, actually. So part 2, find the point of intersection between L1 and the line y equals 2x minus 1. So we have L1, which is y equals minus a half x plus 3. And then we also have the line y equals 2x minus 1. Okay, cool. So we are solving. It says again, find the point of intersection. So it's telling us we're solving simultaneous equations. Again, we have the luxury of y equaling something and then this other y equaling something else. So we can make these two things be equal to each other. So minus a half x plus 3 is equal to 2x minus 1. Cool. What I'm going to do now is I'm going to add a half x to both sides. So that gives us 3 equals 2x minus 1 plus a half x. Adding 1 to both sides because of this minus 1 gives us 4 equals 2x plus a half x. Okay, to get 2x plus a half x, I'm doing 2 plus a half, which is the same thing as 2 over 1 plus 1 over 2. And then just doing a little bit of calculations, making the denominators the same, times this by 2, times this by 2, giving us 4 over 2 plus a half, giving us 5 over 2. So we have 4 equals 5 over 2 lots of x. Okay? Now. To get x, I'm going to multiply both sides by 2 because you've got this 2 as a denominator, and also divide by 5 because you've got the 5 as a numerator. So 4 lots of 2 over 5 is equal to x. Okay, so that's the same thing as 4 over 1 times 2 over 5. I noticed that a lot of people sometimes have troubles remembering this aspect of multiplying fractions, so I keep writing it like this. 4 times 2 is 8, and then that's over 5, which equals x. So we've got x equals 8 over 5. Okay. Now, to work out y, we're just going to substitute it into one of the equations. So I'm going to sub x equals 8 over 5 into y equals 2x minus 1. So I'm going to write y equals 2 lots of, instead of writing x, I'm going to write 8 over 5 minus 1. So we have y equals 2 over 1 times 8 over 5 minus 1. So y equals 16 over 5 minus 1. Doing 16 over 5 minus 1, well, that's just going to be, let's turn that into fractions, so times by 5 to make the denominators the same. So that is 16 over 5 minus 5 over 5, which equals 11 over 5. Okay, so we have x equals 8 over 5, y equals 11 over 5. So the point of intersection is going to be the x coordinate and then the y coordinate. Okay, then let's change colors one more time. Let's change to orange. It says work out the distance between the point 4 minus 2 and the point of intersection from part 2. So we've got the point 4 minus 2 and we've got 8 over 5, 11 over 5. So this does get very awkward in terms of the constants and things like that, but let's go for it. So we have this 4 minus 2, we're going across 4, down minus 2. 8 over 5, well, 8 over 5 is just between 1 and 2. So we go across, and then 11 over 5 is a little bit more than 2, so somewhere here should be fine. So 4 minus 2. 8 over 5, 11 over 5. Again, it's a classic case of Pythagoras' theorem, just with very awkward constants. Now, it's unlikely you'll get this in a GCSE paper in the form of non-calculator because having such awkward constants is just not something typical. But for the practice of doing the subtraction of fractions and squaring fractions and all the rest of it, I encourage you to give it a go without a calculator. So to go from 8 over 5 to 4, well, that's the difference between 4 and 8 over 5. So we're going to do 4 take away 8 over 5 to work out this distance here, looking at the x coordinates. So that's 4 over 1, take away 8 over 5. So times by 5, we get 20 over 5, take away 8 over 5, which equals 12 over 5. So this distance here is 12 over 5. Notice how I'm leaving things as improper fractions because it makes it easier for doing calculations. And then the same here, to go from minus 2 up until 11 over 5, we're going to find the difference between those two things. So we're doing 11 over 5 minus 2. So that's the same thing as 11 over 5 plus 2. So 11 over 5 plus, well, 2 over 1 times by 5 times by 5. We get 11 over 5 plus 10 over 5, which equals 21 over 5. So this is 21 over 5. Now, to work out the distance, so we're just going to call this, let's call it C. just for Pythagoras' sake. So 21 over 5 squared plus 12 over 5 squared equals c squared. Now, doing this calculation, we have 21 squared, which is 441 over 5 squared, so that's over 25. 12 squared is 144 over 5 squared, which is 25, and that is equal to c squared. Okay, 441 plus 144, that is going to be 585. So 585 over 25, why are we not writing, equals c squared. And then, well, we can do it in many different ways, but c is going to be the square root of 585 over 25. There are so many ways in which we can write this. We can write this as the square root of 585 over the square root of 25, which is just 5. If you chose to simplify the 585 over 25, you could also have if c squared is equal to simplifying this, so dividing both top and bottom by 5, we get 117 over 5. So therefore, c equals the square root of 117 over 5. So like that. There are quite a few ways in which we can write it, but something like this is just for checking, just for the sake of practicing our non-calculator techniques. Of course, you can check with a calculator as well that your answer is the equivalent of mine by putting it into a calculator. Okay, let's do question D. Next, straight up, solve the simultaneous equations 2x plus 3y equals 12 and 3x minus 2y equals 6. And it says, solve using elimination. That's what it's asked us for, so I guess we'll do that. Now, in an exam, they usually don't tell you what method to use. You are at liberty to use what you wish, but let's go for the elimination method. So we have 2x plus 3y equals 12, and we've got the equation 3x minus 2y equals 6. So when we're eliminating, we want to make either the x's or the y's the same in terms of coefficients, or at least the numbers. So I'm going to pick the x's to be the same. It seems easy. But to do that, I'm going to have to multiply the entirety of this equation by 3 and this one by 2 to get a lowest common multiple of 6, or a common multiple, should I say, of 6. It doesn't have to be the lowest. Okay, so that transforms the first equation into 6x, 2 times 3 is 6, plus 9y, 3y times 3 is 9, equals 36. 12 times 3 is 36. And then the second equation becomes, well, timesing by 2, 3x times 2 is 6x, minus 2y times 2 is minus 4y, and then 6 times 2 is 12. Lovely, lovely, lovely. Then we can now subtract. So I'm just going to call this equation 1, equation 2. So doing 1 take away 2. 6x take away 6x is 0. 9 take away minus 4 is 13. Be so careful. Be very, very, very careful with those double negatives. 13y is equal to 36. Take away 12 is equal to 24. Okay? That means that y is equal to 24 over 13. Very, very awkward constants, but we're going to work with it because sometimes that's what happens and we just need to work with awkward constants. Now, typically, you wouldn't get very awkward constants because these questions are challenging enough, but the point of these questions is that we're getting over this idea that things are difficult because they're inherently difficult, and it's more so because lots of things are being mixed. So we have y equals 12 over 13. 24 over 13, rather. Okay. So now to get x, we just need to substitute into one of these equations. So I'm going to take this equation, just pick that one, it just seemed nice. So rather than writing 2x plus 3y equals 12, I'm going to put 2x plus 3 lots of the actual value of y now, 24 over 13 equals 12. So that's 2x 3 over 1 times 24 over 13 equals 12. 2 lots of x plus 3 times 24 is 72 over 13 equals 12. And then 2x is equal to 12 minus 72 over 13. Now this 12 can be written as 12 over 1 times by 13 times by 13. So that's going to be equal to 156 over 13. Take away 72 over 13. So we have 2x is equal to, well, 156 take away 72 is 84. So 84 over 13. And then x is equal to 84 over 13 divided by 2. So 84 over 13 divided by 2. But that's the same thing as, so if that's divided by 2 over 1, 84 over 13 times by 1 over 2. Simplifying, divide this by 2, I get 1. Divide that by 2, I get 42. So it equals 42 over 13 times 1 is 13. So we have our final answer of, just to write it in a different color, x equals 42 over 13, y equals 24 over 13. Like that. Okay, next we have part 2. Find the gradient of each line. Oof, they're making us do work. So to find the gradient of each line, it needs to be in the form y equals mx plus c. So these are now equations of lines. So we have 2x plus 3y equals 12. We need to rearrange this into the form y equals mx plus c. So taking away 2x from both sides, we get 3y equals 12 minus 2x. Let's make it look a bit nicer. 3y equals minus 2x plus 12. Better to write it that way around so that it's in the form y equals mx plus c. Then dividing by 3, we get y equals, well, minus 2x over 3 is just minus 2/3 x. And then 12 divided by 3 is 4. Okay, so that's, we get here that the gradient equals minus 2/3. Then, for the other equation, which is 3x minus 2y equals 6, well, we have, if I subtract 3x from both sides, minus 2y equals 6 minus 3x. I'm going to again rewrite it in a nicer form. Minus 2y equals minus 3x plus 6. Dividing both by minus 2, we get y equals minus 3 over minus 2x plus 6 over minus 2. Two negatives divided gives you a positive, so we have 3 over 2x. And then 6 divided by minus 2, a positive divided by a negative gives you a negative, so minus 3. Okay, so that means that the gradient for this line equals 3 over 2. Okay, that's that part done. Now part 3 is saying determine if the lines are perpendicular. Well, to determine if the lines are perpendicular, the gradients need to be negative reciprocals of one another. So minus 2 over 3. If we take the reciprocal, that is 3 over 2 minus, and then change the sign. So in this case, it's minus, so it becomes a plus. So just 3 over 2. And that is the gradient of this. So happy days, they are negative reciprocals of each other. Therefore, they are perpendicular. Another way you can check is if you already know the gradients, take the gradients, multiply them, their products should be -1. So in this case, we get -6/6, which equals -1. Another way of saying that they are perpendicular. Okay, so they are perpendicular. Happy times. Okay, next we're being asked to work out the midpoint of the line segment joining the point of intersection to the origin. Okay, so the origin is 0, 0. Now, the point of intersection, they didn't tell us what the point of intersection was. However, we do know, we do have the, when we solved the equations in part 1, that is telling us what the point of intersection is. Okay? So we had x was 42/13. So that's 42/13 and 24/13. Now, again, let's be ambitious. Let's go for solving these things with the use of a calculator. So we are going to do the same thing. I'm just going to draw a little diagram. Okay, so we have a length of 42/13, just taking the difference in the x-coordinates, and 24/13 here of our right-angled triangle, and we're going to use Pythagoras. So we have 42, that should be 13, 42/13 squared plus 24/13 squared equals c squared. Okay, so that being said, 42 squared is going to be 1,764. 13 squared is 169. 24 squared is 576. Yeah. 576 over, again, 169 equals c squared. 1764 plus 576. Oh, that's a nice one. So it's 2,340 over 169 equals c squared. And then c is just going to be equal to the square root of that. Now, I'm not going to go through working out what that is. We're just going to leave it like that. Okay, so again, another 2 questions that we have done. These are quite long questions, but they're really good in terms of making us think about how to do these types of questions. And it's all using components that we know from GCSE. Okay, they are quite tough questions, but what makes them tough is not each individual component, but the fact that there is so much to juggle. Again, I'm going to leave it for now. In part 3, we're going to have 2 more questions that we do, and we're going to keep going over this, and we're going to see some recurring themes. Until then, take care.